Hi, HEP students. Just going over some problems from practice test number 3 from your SAT book. Unfortunately, we didn't have time to go over these questions in our review session tonight, so I'm recording these for you to review and get a better understanding of these things. So if you happen to have any additional questions beyond this video, please feel free to get in touch with me and to further receive clarification. So looking at practice test number 3, the first problem we're going to look at is number 11. And number 11 sort of sets up like this, where we have this plane that kind of comes across, and then this other line that comes through here, and another one that comes through here. And with this, it tells us that this is X, this is Y, this is Z, this is W, this is U, and this is T. So anytime that we're looking at a geometry problem where we have our plane that goes through and then our cross vertical angles that have been created, we know that we can do backdoor with this sort of problem. And it says its figure is not drawn to scale, so we can't really use we can't go off what we judge on how much the angles are here. We have to go off the rules in which we know about the things. So in the problem, it says in the figure above, lines K, L, and M intersect at a point if X plus Y equals U plus W, which the following must be true. And number 1 is X equals Z. Number 2 is Y equals W. And number 3 is Z equals T. Well, we know what we have here is these vertical angles, so X and T are congruent. Y and U are congruent. W and Z are congruent with each other. And one way we can further confirm this is just by going off and selecting values that would by assigning values to these. So I'm going to say that Y equals 70 degrees. Okay, so this is going to equal 70, and I know from X to Z here, going through this way, this is 180 degrees. I know that. If this is 70, then U also has to be 70 degrees of things. But if I choose a value for Z, let's say what's remaining and everything is 110 degrees between X, Y, and Z, and that if I choose a value, which let me see here, X plus Y equals U plus W of these two. So if I choose a value for this, and I'll say this is 55, and such, that makes T 55, and that if this is 55, that's 70. Well, what remains is 55 things. So we know that. So, and then if Z is 55, then W is 55. So again, this is not drawn to scale, so it's a little bit difficult to ascertain the sort of values these may be, but you have to think about it. Assign a value to Y. U is the same. We know that X plus Y is equal to W plus U. So assigning these values, we know that whatever I assign here is also going to be the same value over here, I think. So these are the two. So X and W are the same, W and Z are the same. So we know these are all of the same angles. That's the reason why 55 degrees is why I've chosen. So if we go off that, X equals Z. Well, X is 55 degrees, Z is 55 degrees, so 1 is correct. Roman numeral number 2, Y equals W. Well, Y equals 70, and the vertical angle across it is 70, but W we've assigned is 55, so that's not true. And then number 3, Roman numeral number 3, Z equals T. Well, Z is 55 and T is 55. So our final answer and the correct one is answer B, for section 3, problem number 11. And kind of moving on from there. Alright, let me get a fresh sheet here. Alright. So the next one we're going to go to is another geometric problem. That is number 18. So if you want to flip there, that's on page 600 of your SAT book. So let me recreate this problem. So we have our column there, line. Okay, so these are not very straight lines, so nope, do not pay attention to that. And then we have our triangle here that kind of intersects. And we also have our triangle here intersects. So this one looks to be a little bit smaller, but it shows that these are, we have isosceles triangles here. And, you know, as indicated by these lines here, showing the two sides are the same. And the problem says the two isosceles triangles are shown above if 180 minus z equals, and that's my z, to y, well then y equals 75. Okay. And it shows that my y is right here. Alright. That's my y. And then this is my z right there. So looking at this, I know that if y equals 75, then this equals, let's mark this out, that's 2y, so that's 150. Alright. And then from there, I need to solve for z. So minus the 150, I then get 130 on this side, and then flip over my z. So z equals, sorry, my bad, minus 150 is z equals 30. So this equals 30 degrees here. Alright, that this angle coming right in here and things. And then knowing what that is, I then have to split these two angles, which are the same because I have the isosceles triangle. So what remains out of that is 150 degrees divided by 2. So then I know that these individual angles here are 75 degrees. Okay, those are 75 degrees. And it wants to know what this x degrees is right here on the opposite side outside of the triangle. So with that, if this is 75, this is 75, this makes this 105, and our answer is 105 degrees. All right. Okay. Excuse me. Apologize for that. All right, get a fresh new sheet up here. So moving on with the same section, section number 3, problem number 20, page 601. It says in triangle ABC, the measure of angle B is 90 degrees. So we know that we have a 90-degree triangle, which is off, so don't pay attention to my drawing here. So this is our 90-degree triangle, doesn't, you know, and then it tells us that angle A, B, and C is what we've signed. It says angle B is 90 degrees, BC equals 16, so I know that this is 16, and that AC equals 20, so do that, that then equals 20. So knowing this is a right triangle and then I have a missing side and I have of this, what am I automatically thinking of? Well, you should be thinking Pythagorean theorem. A squared plus B squared equals C squared. Okay, that's what you should be thinking of. And then going with this, I'm just going to set this up. I'm not going to work it out in completion because my handwriting is so bad. Then I have 16 squared equals 20 squared. So A then equals, we work all this out, equals 12. So this side's end up being 12. So I have all this. So the triangle DEF says that we have a triangle that is similar to triangle ABC. DE. So we got D, we got E, and F. We know it's a right triangle because it's a similar triangle. And it says correspond to vertices A, B, and C respectively, and each side of the triangle DEF is 1/3 the length of the corresponding triangle ABC. So we know that these are all 1/3 in length. What is the value of sine F? So we want to know the value right here. So we'll think of it. What is our, in regards to our trigonometry, SOHCAHTOA, so we know that the sine is equal to the opposite over a hypotenuse, right? And then with that, our opposite, since these are similar triangles, meaning the ratios of them are the same. Okay? Here's sine F that we're trying to find. Our opposite would be this over here, which is 12. 12. And then our hypotenuse is 20. So since we're wanting just the ratio of these, and that we have similar triangles, this will give us our answer which we need. So 12 over 20, which can be further reduced to 3/5, or you can denote it as 0.6, which is also an acceptable answer for that. And this is a grid end, which I know some are struggling with. So it's not as difficult as you think it may look. You have one triangle and set it up and solving for one leg of the triangle with the use of the Pythagorean theorem, and then setting up your other triangle and knowing that the two are similar, and then going with that is it says that DEF is 1/3 the length of the triangle, which that information is somewhat irrelevant in a way. You can perfectly solve this knowing that it's the same ratio that you have with that, and you can use these values just as well to get to your answer. Okay, moving on now to section 4 of practice test number 3. Another problem that I wish to cover. Let me see. Okay, this is number 21. Nope, don't need to save. Excuse me. So number 21 reads, of the following 4 types of savings account plans, which option would yield exponential growth of the money in the account? So we know what we have: linear, and then we have exponential. So if we're looking at our graph, our linear growth, it looks like this in a straight line. It's consistent year after year. We know what to expect, and that the units are the same in each increment. So now if we're looking at exponential growth, it may start off and then it kind of takes off like this, half of a U shape. So each unit is being multiplied by a factor and increasing in a way. So looking at our options here, choice A says each successive year 2% of the initial savings is added to the value of the account. Well, 2% is added to the value of the account each year. Well, that's something consistent from the initial savings. So if our initial savings was $1,000 and we're taking 2% of that, then that is only yielding us $20 per year. Okay, that's not going to grow us at a very accelerate at a very good, fast rate. Option B says each successive year, 1.5% is of the initial savings and $100 is added to the value of the account. Again, 1.5% of the initial savings, so whatever this initial investment was, 1.5% continue to be tacked on. That and $100 is added, so that's something consistent year after year. You expect the same amount, so that is another linear explanation. Choice C says each successive year 1% of the current value, so whatever it is at that very moment, 1% of the current value is added to the value of the account. So whether that's 1,000, 2,000, 3,000, 4,000, it will continue to move along with the current value, which yields and shows exponential growth. And then option D, each successive year, $100 is added to the value of the account. Well, again, that's a consistent amount. That's an expression of linear growth. So that is not it. So choice C is your answer. Okay, all right. Moving on to the next one. So the next problem, section 4, problem 27, and on page 612. So this one can be kind of tricky, but you sort of have to break it down, and I encourage you to use the trial, a little bit of the backdoor and the trial and error method that you could use for this one. So the problem says a rectangle has altered by increasing its length. So the length of the rectangle is increasing its length by 10%. So the length increases by 10%. Okay, we know that. And then it says, and decreasing its width. So its width then decreases by p%. So it doesn't tell us what this value is. We just know that we have to figure it out. And it says if these alterations decrease the area, so the area of the rectangle is decreased by 12%. So these are the parameters that were given. And it's like, how do we go about finding it out? It says, so what is the value of p? So we need to figure out what percentage of the width was decreased to give us and yield a 12% decrease in the total area. So I'm going to pick some values. I'm going to draw my triangle, or not my triangle, my rectangle, I'm sorry. You know, maybe I should use these little shapes here. That would probably be a little bit better. Let me try and do that. Let's see. Let's see what happens here. Whoa, works so much better. Not sure why I'm just now thinking of using that. So I've chosen, and what we can start off with is with backdoor here. And I've chosen that my width is 4, okay, and that my length is 10. Okay, so we know that length times width equals our area. So with that, 4 times 10, so our area is 40. Okay, and that we want a decrease of 12%. Draw another rectangle. So this one happens to be a little bit smaller. All right, and if we take 40, since we want a decrease of 12%, we're going to take 40 and multiply this by 0.88, and that will yield our area for our new smaller rectangle, which, if we add that up, yields 35.2. Okay, that is the area of our new triangle with a 12% decrease. Okay. You can take 40 times 0.12, which would be 12%, and then you just take that value minus 40. But for the sake of cutting out one step, I times 0.88 to arrive to that number. So it tells me that the rectangle was altered by increasing its length by 10%. So if my length is 10, adding 10% to it would yield 11 and things. And then from there, I need to figure out the percentage of decrease. So this was backdoor, choosing a value to get me something that I can operate from. Now here I can go from my answer choices and use trial and error. So this is a good indication of seeing the use of both strategies, okay? So I have 12 is the answer choice A, and then over B, I have 15 and such, and then C equals 20 things, okay? And then I think D, what is D? D is 22, okay? So I honestly, I chose the right choice. I chose to go with C the first time around. Excuse me. So if the width is being decreased by 20%, okay, that means this is my width here times actually times 80, so this would result in 80%, which if I do 4 times 0.8, then this yields 3.2. Okay, so if I take 3.2 times 11, it then yields me 35.2, which is my answer. It matches up. 20% is my answer choice for this one. Alright, so there's how we work that problem. We're going to continue to move along here. Now moving to question number 34, it reads, in a circle with center O. So we have our circle there. Let's get this circle there. Alright, there we go. That looks good. And we have our center. Let's say our center is right there and things. And it says AOB has a measure of 5 pi force. So thinking about this, we know that a whole circle is equal to 2 pi. Okay, and that we know 5 force is larger than 180. So 180 equals, remember, 180 degrees equals pi. Okay, so 5 force would be larger than that. So coming through here, we'll say this is our angle that we have here. So we'll say, alright, this is A, this is a very large angle, OB. And this tells us that this is 5 pi force. So what we want to know is what fraction is this of the whole circle, which the whole circle is 2 pi, and going from there. So we basically just set it up, 5 pi over 4 times 2 pi, and we want to know what our ratio is there, and then going through that and multiplying it, we then get 5 over 5/8 is our answer, because the pi's cross out and things, and then multiply and doing the fraction there, we get 5/8. So this angle AOB is 5/8 of the circle in radians. So 5/8. All right, moving along here. Number 35. It reads, an online store receives customer satisfaction ratings between 0 and 100 inclusive. If the first 10 ratings, the store received the arithmetic average, or the mean, of the ratings was 75. So we know that their average is 75. Okay. Make that a little bit more distinguishable with a 7 there. Yeah. What is the least value the store can receive for the 11th? So we want to know what the 11th rating is, which we don't know. And still be able to have an average of at least 85 for the first 20. So for 20 ratings, our average is 85. So it's increased by 10 over the last 10 ratings. So if the first 10 ratings average 85, we know this equals a score, cumulative score of 750. Okay, we know that. And things we don't, and we know with 20 ratings at 85, that if we multiply this, this gives us 1700. Okay. Minus that, so with 1700 minus the 750, we know that we are left with a value of 950. Okay, so over the last 10 ratings that we received, so 11 through 12, we have to have a cumulative value of 950 points among the ratings and things. And it's asking what is the least value that we can have there for that. So if we need to know what our average is, we'll divide by the last 10 remaining values, and our average for those is 95. So we know that. And I know that 9 of these, the maximum value which I can have out of these 9s, so 12, essentially 12 through 20, that the maximum value that I can have is 100. I can't go any higher than that. So that leaves me, that gives me 900 points. So out of the 950 that remain, I can accumulate a total at the very most 900 points. So 950 minus 9 equals 50. So the 11th rating could be a 50, and then the remaining 12 through 20 could be all hundreds, and we'd still achieve a arithmetic average of 85. Getting close to the end here. Alright, so question number 37. And it reads, if shoppers enter a store at an average rate of R shoppers per minute, and each stays in the store for an average time of T minutes, the average number of shoppers in the store N at any one time is given by the formula N equals RT. So this first part, 37, it's not really relevant to use that information that we have there. It reads that Little's law can be applied to any part of the store, such as a particular department or the checkout lines. The store owner determines that during business hours, approximately 84 shoppers per hour. So we have a, that looks like an average rate per minute. So we have 84 shop per hour and things. And then it tells us make a purchase, and each of the shoppers spend an average of 5 minutes in the checkout lines. At any time during the business hours, how many shoppers on average are waiting in the checkout line to make a purchase at the Good Deal store? Well, we have hours here, and it tells us that the average person spends 5 minutes in the checkout line. This is hours, this is minutes, so we have to do a rate conversion there. So we know there's 60 minutes in every hour. 5 minutes of those is average spend. So with that, that is 12. Okay. So there's breaking that down. That's 12. And then from there, we have 84 shoppers. Okay. 84 shoppers. So you may ask, like, why 12? But these are the units. So there's 12 units, okay, that are being broken up into these 84 shoppers per hour. So we've made this conversion of things. So if we divide this by 12, we get the answer of 7. So in the hour, every 5 minutes, there's 7, average of 7 shoppers who are in the checkout line. 7, 7, 7, 7, 7, 7. We do that 7 all the way 12 times, and we get accumulation of 84 shoppers and things. And that is our answer. Okay, so last problem here that we are going over, and number 38. So we have our formula, which is given, which we'll need to use at this time, that n equals rt things, and n equals the total average number of shoppers in the building. So n equals the average shoppers at one time, and then r equals shoppers per minute. So if we're looking at this is the average rate of shoppers per minute that enter the store. So let me, sorry. N equals is the average number of shoppers in the store, where N is at any one time things. So in R equals shoppers per minute stuff that are entering the store. So N equals the total number that may be in the store at any one time. R equals a number that are entering the shop per minute. And then T is the average time that they stay in the store. So, so there's that. It reads, for the new store, the owner estimates that during business hours, an average of 90 shoppers per hour enter the store, and each of them stays an average of 12 minutes. The average number of shoppers in the new store at any time is what % less than the average number of shoppers in the original store at any time. So anytime we're doing with rates, I always suggest that you try to set up tables, and that would help you out with this. So we have the old, okay, and then we have the new. Get my table going there. Here we go. All right, and then we have our values in which we're looking at, and so we have R. So R that's being given to us in this problem, start of the promises, is that the R is our shoppers per minute who enter the store. All right, and then the old, that is 3. And then in the new, it's telling us that an average of 90 shoppers per hour enter the store. Well, we're not interested in per hour. We're interested in how many per minute and things. So is what we're trying to figure out there, and make this conversion. So if we have 90 shoppers who enter per hour, and we're trying to go to minutes, and we have 60 minutes, that then yields us 1.5 shoppers per minute. Okay, so hopefully you can see that. So 3 shoppers are entering the store in the old one. We got 1.5 per minute in the new one, and then we have our T, which is telling us that and the first one says they stay an average of 15 minutes, so the time in which they stay in the store. So here we know is 15 minutes. And then in the new one, it's telling us, if we look here in the problem, it says each of them stays an average of 12 minutes, so they're staying 3 minutes less in the new store. It tells us also as well as that our N So our n, if we do this math, we know that 3 times 15, which we see we have our formula in n equals r times 2, or t. So 3 times 15, which then tells us that 45 shoppers are in the store at any time, is what they can expect. Here, so we do the same thing. So 1.5 times 12. N equals RT, so R is 1.5, T being 12, 1.5 times 12 gives us a value of 18. So we don't stop there. It's asking us what percent less than the average number of shoppers in the original store at any time in the new store. So we want to know what the percentage is that we have, or the percentage of fewer people who are in the new store. So again, we want to do our change. So our change in percentage, if you remember, that is actually supposed to be a triangle. It's a very poorly drawn one. As we have is the of our initial minus our first value divided by the original. So our original is 45 minus 18 divided by 45, and we do this, we then get a value of 27 over 45. Do the math that's further there, we get 0.600, which you may express it like that, or in percentages, which 6.0 and things. So our answer is the new store is bringing in 60% fewer customers, or 60% fewer customers in the store compared to the old one. Actually, I just checked the answer. They do, since they are asking for percentage, our correct answer is 60, which you really don't have to carry out the decimal in this particular point, since it's not being asked. Things. Alright, well, I hope you find that all to be very useful, helping to explain some things, and if you were to be presented with similar problems, you have a better understanding of how to set those up and work through them. So thank you so much, and if you have any questions, please feel free to get in touch with me. Thanks. Bye-bye.